Good morning, all of you. Welcome to Sri Jayendra Rank Zone. So, in the previous session, we have done questions based on coordination compounds. Now, in this session, also we are going to do the same thing because this chapter is very important. That's why we have made 100 questions for you to understand easily the entire concept from all the topics of coordination compounds. So that's why I'm giving you these questions. So please practice. If you practice this total 100 questions also, the last lecture, that is lecture number 7, 8, and 9, that is more than enough in this chapter. So please listen carefully. Now let us start now with the new questions. Which one is an outer orbital complex? Very, very important. Outer orbital complex means it should have weak field ligand. Should have what? Weak field ligand. So what are weak field ligands? What are strong field ligands? We have already discussed in the lectures. Again, I'll recap it. Weak field ligands are nothing but what? So which are considered as weak field ligand? Weak field ligands are nothing but here cyanide is strong field ligand and ammonia is also strong field ligand. And here which one is outer orbital complex? In both of these, which is weak, we have to check now. So weak field ligands will form outer orbital complex and high spin complex. So answer is A because it is nickel hexaamine, and here manganese cyno, and here hexaamine is also there. But the oxygen state of nickel is +2. So the oxygen state of nickel is +2 here, lower oxygen state, weak field ligand, and lower oxygen state of the metal, lower oxidation state. And amine is strong field ligand only, but still it is considered as in between these. Which of the following is outer orbital complex? Out of this could be the outer orbital complex. Weak field ligand generally forms outer orbital complex. Next question. Both nickel carbonyl compound, tetracarbonyl compound, and nickel tetracyano compounds are diametic because they do not have any unpaired elements. The hybridization of nickel in these complexes are hybridizations. So it is sp3, 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 dsp2, dsp2, sp3, and dsp2, sp2. So how to find hybridization in these compounds? So which can form have diametic means they should not have any unpaired electrons. But since cyno is there, cyanide is there, it has strong field ligand and carbon monoxide. So definitely one should be sp3 and another should be sp2, sorry, dsp2. So answer is, just I'll close it and just go back to the question. So answer is option C. It is option C. So it is no, so this is option B because in this is sp3 and this should be dsp2. You can check the answer in hybridization concept. This is based on valence bond theory. Valence bond theory. Next question. Question number 3. Let us start now. The species having tetrahedral shape is, which is undergoing sp3 hybridization, will have tetrahedral shape. So palladium cyanide, palladium chloride, nickel chloride, and nickel cyanide. So which will have sp3 hybridization? Definitely this is dsp2, dsp2. So sp3 hybridization only will form tetrahedral shape. Otherwise it will go square planar complex, square planar. dsp2 will go what? dsp2 shape will have square planar complex. So with this easily you can find out which is tetrahedral in shape because the hybridization of the central atom should be sp3. So let us check the answer now. So it could be nickel cyanide taken 4 times because this one we have seen in the last previous question only. So it is sp3. Next question. Which one of the following is an inner orbital complex as well as diametic in nature? Generally, inner orbital complex means they have parametric, but still they are diametric. And first of all, we should see in the orbital complex means strong field ligand. So here all are same ligands. So zinc, ammonia, amine is there. So strong field ligand will not apply. So only we have to check the oxygen state of the metal. So it is +3 here. Cobalt, it is again +3 here given already. And nickel is +2. And this is zinc is +2. So you can write the oxygen state of metal already given. So straight away we can find out. So Zn +2 means what? Actually Zn is 3d10 4s2, 3d10 4s2 because zinc is argon 3d10 4s2. Oxygen state is Zn. So 4s2 means 4s0 it becomes. So 3d10 all are paired. So all are paired means it should have no unpaired electrons. Then only it can be diametric in nature. but still it is undergoing inner orbital complex. So answer is for this, it is option B they have given. Cobalt plus 3, let us check for cobalt plus 3 also. Cobalt plus 3 means cobalt atomic number is 27. So it is in plus 3 state means it should become 24. So definitely this will have unpaired electrons because cobalt plus 3 means 27 argon, 27 means 18, and here 4s to 20, and here 3d7. 3d7 means 3 means you should have 3d6 configuration. 3d6 means definitely it has unpaired electrons. So unpaired electrons means it should not be diamantic in nature, it should be paramagnetic in nature. So answer is definitely D. There is no other option. So definitely D. It is not B. It is D. Some questions they have given wrong options, so please note it down. Next question. The value of spin-only magnetic moment for one of the following configuration is 2.84 Bohr magnetic. The correct one is definitely it should have n is equal to 2. Number of unpaired electrons is equal to, then only mu is equal to root of n into n plus 2. N into n plus 2 is nothing but 2 into 2 plus 2. So 2 fours are 8. So root 8 is equal to 2.84 Bohr magneton. So it should have two unpaired electrons. N is equal to 2. So D2 in field, weak field ligand, D4 in strong field ligand, D3, D5. So straight away we can say 2 is there because N should be equal to 2. So answer could be option B, as I told you, because D2 in weak field ligand. Next question. In the complexes FeH2O taken 6 times 3 plus, FeCN taken 6 times 3 minus, FeC2O4 taken 3 times 3 plus, and FeCl6 3 minus. The most stability is shown by. So in all the cases, the oxygen state of ion is plus 3. But here number of ions is 0. But here it is plus 3 again. But number of ions becomes 3 because 6 ions will form. And here number of oxygen state of ion is plus 3 because this is neutral ligand. And here number of this is minus plus 3. So in all the states ion is plus 3 state, but more stability is given by number of ions. More stability is given by number of ions. So answer it could be option C because it is bidentate ligand. It is bidentate ligand. It can form 3 moles of C2O4 2 minus. So since it is bidentate, see, moving all by monodentate, but it is bidentate, so it is having more stability. More stability. Next question. Among the following, the compound that is both paramagnetic and colored is. Paramagnetic means automatically it will have color because paramagnetic means it should contain unpaired electrons. It should contain what? Unpaired electrons. So in which case it is containing unpaired electrons? Let us check now. Potassium dichromate, the oxygen state of chromium is plus 6. And here the oxygen state of titanium is NH4 taken twice, ammonium titanium Cl6. So it should be plus 2, and this should be plus 2 again, plus 1 actually, because when potassium is outside. And this should be again 4 minus 3 should be plus 1. So copper in plus 1 state is not paramagnetic, it is diamagnetic. And chromium in plus 6 state and titanium in plus 2 state. Let us see now how many number of unpaired electrons will be there for titanium and chromium. So answer is copper plus 1 state, it is plus 1. No, it is 2, and here it is plus 1. So it is paramagnetic as well as colored. So answer is this is K, no, actually this is K, and this is here 3 plus 4 minus 1. So this should be plus 1, this should be plus 2 actually. If copper is plus 2, it is colored. It should be plus 2 because only one K is present. So answer is C. Next question. Among the compound which is not pi bonded organometallic compound, they should not contain pi bond. Pi bonded organic metallic compound. So Fe N5, that is neta 5, C5H5 taken twice, N6C6H taken twice, CH3 taken 4 times tin. This is methyl group surrounding with the tin, and this is PDCl3 N5 C5H5 taken twice. This question is quite typical. So anyway, these are all containing pi bonds. Easily we can say because this is pyridine, this is also pyridine, this is also benzene. So these are all contains double bonds. Since double bonds is there, they should definitely contain pi bond. So that's why they are asking not pi bonded. So answer is this. This is organometallic compound. This is CH3 is methyl. Methyl group does not have any pi bond. It should not have any pi bond. So answer is fourth option. Next, which compound is formed when excess of potassium cyanide is added to aqueous solution of copper sulfate? So definitely cyanide will replace copper sulfate ions. So which compound can form? So the stable compound we have to check for this now. So answer is K3Cu taken CN taken 4 times. So this is a stable compound because the oxygen state of copper is +1 here. So it is more stable. So answer is this. When excess of potassium cyanide is added to copper sulfate solution, it will form tetracyano, potassium tetracyano copper 2. Potassium tetracyano copper 2. Next question. Which of the following ligand has highest delta naught value? That is crystal field split. What is delta naught? Delta naught is equal to crystal field splitting energy. So crystal field splitting energy, this is En bidentate ligand, F minus monodentate, OX that is oxalate again. OX is nothing but what? C2O4 2 minus, and cyanide that is Cn minus. So which will have the highest delta naught value? Strong field ligands, they are given weak field ligands as well as strong field ligands. These two are weak field ligands and these two are strong field ligands. So strong field ligands will have highest delta value. So answer is Cn. Answer is what? Because strong field ligands will have delta naught value highest. It is equal to 0.6. Next question. Which of the following has lowest value of paramagnetic behavior? So for this we can say which contains weak field ligands, or you can say which contains less number of unpaired electrons. Number of unpaired electrons that will have lowest paramagnetic behavior. So we can find out the unpaired electrons of chromium in +3 state here, and here it is manganese in +3 state again, and here iron is in +3 state again, and cobalt in Cn taken 6 times, so it is again +3 state. So in all this, which will contain maximum less number of unpaired electrons, that is the answer. So easily we can see the unpaired electrons, how to calculate unpaired electrons by seeing the configuration. So option is cobalt +3, because it contains less number of unpaired electrons. Because cobalt is 27, so cobalt is 27 means argon 4s2 3d7. So 3 electrons means it has cobalt +3 means argon 4s0 3d6. So it has 4 unpaired electrons. How many unpaired? 4 unpaired electrons. Remaining all might be 5. So that you can check it out easily, you get the answer. Cn is a strong field ligand. Cyanide minus ion is a strong field ligand. This is due to the fact it carries negative charge. It is pseudo halide. It can accept proton from metal. It forms high spin complexes with metal. Generally, high spin complex will not form by strong field ligands. They will form low spin complexes. So it can accept proton from metal. It is a pseudo halide. Pseudo halide means it is nothing but like halogen, but it carries negative charge. So answer should be, what could be the reason for strong field ligand? It is pseudo halide, because it just like behave like halogen, because it can form NaCN minus and Nc minus also. Ambidentate ligand. Ambidentate ligands is also nothing but pseudo halide. A square pyramidal complex is formed by hybridization of which of the atomic orbitals? Square pyramidal complex. Usually square pyramidal complex is formed by dsp2 hybridization. dsp2. So one d orbital, one s orbital, two p orbitals. So one d orbital, one s orbital, two p orbitals. So two p orbitals, it could be px and py. One d orbital, it could be dx square minus y square, dxy, and one s orbital. So in all the cases, they have given all the possibilities. So definitely this could be very important question. So dx square minus y square, d is z square. And I think the option for this answer will be, it is dx square minus y square, because it is higher energy level. Dx square minus y square will form Eg, T2G. and these will form XY, YZ will form T2G. So T2G and EG. So that's why this will have hybridization square, which are atomic capital. So it is forming DsP2. Definitely it is SPX, EY, and DX square minus Y square. S, one S orbital, one PX orbital, one PY orbital, and DX square minus Y square orbital. So like this we have to do it. Next question. Which of the following compounds is not colored? Not colored means it should be containing n value 0. What is n? N is called number of unpaired electrons. So in which compound number of unpaired electrons is 0, that compound is colorless. So easily you can find n value for all these things. And if you find here cadmium CCl4 Na2, the oxygen state of cadmium is here, it is +2. So if you see cadmium +2 configuration, definitely it have no unpaired electrons. So as it is containing no unpaired electrons, definitely it is not colored. It is not colored. If n is equal to 0, no unpaired electrons, it is diamagnetic and also colorless. It is diamagnetic and it is also colorless. It is also colorless. So these things we have to check it out. Next question. Some salts, although containing two different metallic elements, give test for only one of them in solution. Such salts are called complex salts, double salts, normal salts, none of this. Straight question, it is complex salts. So they can, even they contain two different metallic elements, but it can give test only for one of them in the solution. So all complex compounds, they will give confirmatory test for the metal in the solution form. Next question. Cis-trans isomerism is found in square planar complexes of molecular formula Ma2B2 because square planar complexes means Ma2B2. Why it is Ma2B2? Because they will go, square planar complexes will go geometrical isomerism. Geometrical isomerism. So in which of the following molecules will exhibit geometrical isomerism? Easily you can find out the answer. So for this the answer will be, as I told you, it is Ma2B2. Ma2B2 will undergo geometrical isomerism. Cis-trans isomerism is found in square planar complexes of molecular formula Ma2B2. In the lectures, I have given all the molecules which will show type of molecules which will show geometrical isomerism. That is very, very important. So please note down in your classworks. Next, which of the following gives maximum number of isomers? Isomers. Number of isomers means it should have number of ligands also. So it is 2 and it is here, it is 2 again, and here it is 4 plus 2, 6, and here it should be 2 plus, actually it is 2. So the answer could be D because it has ambidentate ligand because it can attack to NCS as well as SCN. So SCN is there, NCS is there. So it has maximum number of isomers. It has maximum number of isomers. Next question. Methyl isothiocyanate. Methyl isothiocyanate means NCS is indicated by its chemical formula. Isothiocyanate means this is thiocyanate and isothiocyanate means it should be attacking from nitrogen. So answer is definitely option A. It is option A because it is NCS. So it can attack from sulfur, it can attack from nitrogen. So with sulfur it is called thiocyanate. It is called thiocyanate. With sulfur, the metal it is called thiocyanate. With sulfur it forms thiocyanate. With nitrogen it forms isothiocyanate. So let us check the answer. It is option A. Yes. Next question. Platinum, bromine, chloro, nitro, NH3 on ionization gives the ion. So it can form Cl minus, it can form Br minus, it can form I minus, it can form NO2 minus. So anyway, iodine is outside. So here this is Cl minus and Br minus is there. NH3 is neutral ligand, NO2 minus also it can form an iodine. So which will form first? It will form iodine minus definitely because iodine is outside. First outside, then it will go for inside one. So answer is C. FAC and MEM isomerism associated with the general formula. This is direct question. You can just check it out. So answer is M83X3. Facial and meridional. What is FAC? Is facial. It is facial and meridional isomerism. Meridional isomerism. Usually it will be extracted by geometrical isomers. Geometrical isomers like cis and trans. So which compound will exhibit type like that? It is forming by Ma3X3, where X is called halogens. X is called what? Halogens. Next question. Both geometrical and isomerism was shown, optical isomerism was shown by this compound is very, very important, this question, because we have discussed in the lecture also which compound can show both geometrical as well as optical isomerism. Optical means it should have at least one bidentate ligand. So this is Ma2B2. This is just like Ma2B2. So definitely this will undergo geometrical as well as optical isomerism. So answer is C. As I told you, this is in the form of A2B2. So Ma2B2 means it will show geometrical isomerism. Geometrical isomerism. And since A is bidentate ligand, since A is bidentate, bidentate ligand, so it will show optical isomerism also. It will show optical isomerism. Optical isomerism means to exhibit optical isomerism, definitely one bidentate ligand should be present. If no bidentate ligands, no optical isomerism. Next question. Optical isomerism is exhibited by a complex with coordination number 4 with a bidentate ligand, coordination number 4 with two bidentate ligands, coordination number 6 with a bidentate ligand, coordination number 6 with three tridentate ligands. So it is simple. At least one bidentate ligand should be there. So, and here coordination number 6 with the bidentate ligand. Straight away you can say coordination number 6 with bidentate ligand, because this will not exhibit optical isomerism, and this is more than this. So that's why answer is third option. Very, very important. So optical isomerism is exhibited by a complex with coordination, because optical isomerism definitely should have octahedral complex only. Only optical isomerism is exhibited only for this. Optical isomerism is exhibited only for octahedral complexes. Octahedral complexes means coordination number should be 6. Octahedral, no tetrahedral complex. Geometrical can go for tetrahedral as well as octahedral, but optical isomerism is purely for octahedral complex, and in that one bidentate ligand should be there. Bidentate is compulsory. Bidentate ligand should be there. So due to which what happens, these two are compulsory conditions. So for this coordination number is equal to 6. So bidentate. So answer is coordination number 6 with a bidentate ligand will show optical isomerism. Very, very important question. So you please note down what I'm writing on the slides so that easily you can copy it on in the classwork. If you copy it on, you can understand that question. So it's my sincere request is that, so you have to write the question with all the options and then you can discuss the answer, as I have written the solution also here. Each and every question we are writing the solution part, that is hint part I'm giving. So if you write all those and if you refer the notes easily, you can understand this concept and you can do more number of questions from other books also. Next, which of the following compound shows optical isomerism? This is again a typical question. We can see, as I told you, this question. The previous session, this question has come zinc chloride. This is wrong because ammonia is monodentate, chlorine is monodentate, cyanide is monodentate. Only we have bidentate ligand because all these three are monodentate ligands. Chlorine is monodentate. Amine is also monodentate. Cyanide is also monodentate. And to exhibit optical isomerism, definitely should have one bidentate ligand, and oxalate ion is bidentate because it is formed C2O4 minus. So it is bidentate. Since oxalate ion is bidentate, so answer is third option. It is directly bidentate ligand will show optical isomerism. So please note down, to exhibit optical isomerism, at least one bidentate ligand should be present. To exhibit optical isomerism, at least one bidentate ligand should be present. Very, very important. Next question. Two complexes are given below. They are nothing but En is given, An, and En is changing their centers. So definitely due to the presence of En, that is bidentate ligands, they will have position isomers, optical, geometrical, identical. So answer is C, because optical isomers will have bidentate ligands. Due to the presence of bidentate ligands, they exhibit optical isomer. So answer is C. Without any doubt, we can say it is C, option C. But is identical they are showing, it is A and A opposite sides, cis and trans. So En opposite side should be identical also. Actually, yes, it is identical only. So it is identical because En opposite sides, here also En, A and A opposite, here also En. So these should be identical, not optical. Optical means they should have dextro and lavo form. These are not dextro and lavo form. Not dextro and lavo form because both are similar. So they are nothing but identical isomers. So they are called as identical complexes. Next question. The number of geometrical isomers possible for CO NH taken twice and O2 taken twice is, and to find number of geometrical isomers, we should have the formula. Number of geometrical isomers, please note down. Just I'll write here. The number of geometrical isomers possible for the compound, number of stereoisomers possible for the compound. It is of the type. What is the type of this compound? It is A3B3. So for M A3B3, it is of the type M A3B3. So number of geometrical isomers possible for this type of compound is, you can see the table. So it is number of geometrical isomers is 2 geometrical isomers for this compound. Number of geometrical isomers, number of optical isomers 0, number of stereoisomers. So number of optical isomers 0. So only number of geometrical isomers is 2. So MA3B3, number of geometrical isomers is equal to 2. This table is given. So for this number of stereoisomers in octahedral complex, they have given one table. That table also I'll upload it in the PPTs. Easily you can understand. So answer is option A. Option A. Let us check now. So it is option A. It is correct. Next question. So if you want, I'll write here. Definitely, if it is better, number of geometrical isomers for different molecules, just write here. So here itself, if you write, it will be easy for you. Next, for the molecules MA4BC, number of geometrical isomers will be 2. Only I'm writing geometrical isomers. And here optical isomers also I'll write optical isomers for different molecules, octahedral complexes. The first case is 0, second case also is 0. Next, for the molecule MA3BCD, number of geometrical isomers will be 4 and optical isomers will be 2. Like that, you please note down for the molecule MABCDEF. MABCDEF. This is very, very important. Number of geometrical isomers will be 15 and optical isomers will be 30. This is the highest one. So total it is 45. Number of stereoisomers, sorry. Stereoisomers 15 and this should be 15 again. This should be 15. Number of optical isomers is also 15, highest one. So total number of stereoisomers becomes, stereo means both geometrical and optical now. So stereoisomers is equal to, number of stereoisomers is equal to, I can write here in box. In the first case it is 2, second case it is 2, third case it is 6, fourth case it is 30. So like this you can get the answers easily. So for MA3BCD type, number of geometrical isomers is 4 and optical isomers is 2. So total number of stereoisomers is 6. Like that you can find out. So here some I have given. Please note down in your classwork. It is very, very important. You may get this type of questions in the entrance exams. At least for a few molecules you learn. Next. The phenomenon of optical activity will shown by, so En right side, A, B, A, M, En opposite side, B, B opposite side, En opposite, A opposite, and here B, B, B metal, and A is given. So En is definitely, it should have one bidentate ligand. So this should be answer B because it is containing only one bidentate ligand. Only one. This will go left side. This is called dextro, and other, if you keep this in the front of mirror image, the En will go left side. So only one bidentate. Here two bidentate ligands are there. That's why it will not produce. And here also two opposite sides, so they cancel out. And here no bidentate, and here also only no bidentate. So answer is absolutely B because this En will go left side, will come to left side if you keep in front of mirror. If you keep in front of mirror, so that's why it will show optical activity. It will show what? Optical activity. So to show optical activity, one bidentate ligand should be present. At least one bidentate ligand should be present. And En is bidentate ligand. Since En is bidentate, so it will show optical activity. And here also you might get the question. Here also En is present, but they are present in opposite sides. There is no change. These two are identical isomers. These two are, so this is identical isomer. This will not show because only left and right position should be changed. Left side and right side, it is both sides. En is there, so it cannot produce optical activity. Those are called meso compounds. Those are called what? Meso compounds in identical isomers. Next question. The number of isomers possible for square planar complex. Square planar complex, number of possible isomers. You can see here, octahedral complexes are given. Now we have to see square planar complex, number of possible isomers for the type here. Number of square planar complexes, number of possible isomers for square planar complex. We can see here palladium, chlorine, bromine, SCN. So this contains 3. So answer could be 4. So number of square planar complex will be total because Cl can go outside, Br can go outside, SCN can go, and this is one formula. So automatically it can produce 4 isomers. How many isomers? 4 isomers. You can see here, for example, K2, PD, Br2, SCN, chlorine outside. This is first isomer. Second case, K2, PD, Cl, SCN, Br2 outside. This is second isomer. And third isomer, so K2, PD, Cl, Br2, SCN outside. So anything can go. So these are the 3 and plus 1, 4. So total it is 4 isomers. Next question. Which of the following complexes can exist as optical isomers? Optical isomers means it should have at least one bidentate ligand. So this is bidentate, this is also bidentate, this is also bidentate, but it is twice. And this, anyway, C and D are ruled out. So A and B we can check. So FeC2O4 taken twice, 3 minus. And this is whether it is square planar complex or octahedral also we have to check. So definitely one should be octahedral complex. So answer is option A and C. Option A and C, since they contain bidentate ligands. So they are nothing but can exist as optical isomers. These two are, can exist as optical isomers because they can form enantiomers. And here only one bidentate ligand is there. And moreover, it is not square octahedral. It is not octahedral. Even though it contains bidentate, it is not octahedral in shape. Whereas these two are in octahedral shapes. And this is ruled out. So answer is A and C because this is octahedral. This is also octahedral. Octahedral means coordination number should be equal to 6. Here coordination number is 6. Here also coordination number is 6. But here it is coordination number is not 6. So you can check this. Next question. Select most stable complex. Most stable complex means we have to see number of ions is most. So it is definitely, this is most stable because it can form optical isomerism. Next question. For an octahedral complex, which of the following d electron? For an octahedral complex, which of the following d electron configuration will give maximum crystal field splitting energy? High spin with the d6 configuration, low spin with the d5, low spin with the d4, high spin with d7. Anyway, strong field ligands will have strong field ligands Strong field ligands will have maximum delta net null value. So in this case, high spin we have low spin. Definitely strong field ligands will have low spin complex. So low spin. So low spin D4, low spin D5. So it has 5 unpaired electrons. This has 4 unpaired electrons. So answer could be option B, because strong field ligands only will have low spin, and low spin D5 means n is equal to 5 and n is equal to 4 here. So definitely answer is option B. This is the very important question. For an octahedral complex, which of the following d electron configuration will give maximum CFSC? So strong field ligands will have maximum delta naught value. First point. So strong field ligands will have, second point, low spin. In that, number of unpairs is maximum for D5. So definitely the answer is D5. Low spin is D5. And high spin will have big field ligands will show high spin complex. Next question. In Jesse's salt, central metal atom has oxidation number. So let us see now what is Jesse's salt formula. I'll just write it here. Please note down. Jesse's salt formula is Jesse's salt formula. Just note down this formula, all of you please note down. It is nothing but potassium, platinum, chloride, dot H2O. Outside it is water. So the oxygen state of platinum is +2. The oxygen state of platinum is what? +2. This is an ion of the AS table. So potassium trichloro, this is potassium trichloro, platinate 2. Potassium trichloro, platinate 2 is called Jesse's salt. So oxygen state of central metal atom is 2. Straight away we can say the answer. So option is B. Option is what? Second option. That is B. So like these questions are important for objective. Maximum number of questions we are doing in this chapter, because as I told you, from this chapter you are going to get at least 3 to 4 questions in any entrance examination. So we have done already 32 questions in this lecture. Now we are going to discuss new topic. So some more questions we are going to discuss in the same. Now in this session only I will try to discuss. So let us see now. So let us start now. More questions so that we can finish up this entire chapter. So more questions in this, we have how many? We have 23 questions. So more questions we'll do so that we can wind up this chapter successfully. And let us start now. So some more questions. The number of chloride ions which would be precipitate when CrCl3 4NH3. This is based on what topic? Is based on Werner's theory. What is this? Werner's theory. So number of chloride ions precipitated when it is treated with silver nitrate solution, CrCl3 4NH3. So easily you can get the answer from Werner's theory. So answer for this option is 1, because CrCl3 4NH3 is weak field ligand. So it is, answer is 1. Next, yes, I clear the drawings. Next question, let us start. An octahedral complex is formed when central metal atom undergoes hybridization among the orbitals. It can form, octahedral complex can be formed as sp3d2. Straight away answer D. Even if they are given d2 sp3 also, it is correct. So it can form either d2 sp3 or sp3d2. d2 sp3d2 is outer orbital complex, outer orbital, and d2 sp3 is inner orbital complex, inner orbital complex. So definitely this is very, very important. So answer is what? It is option D. Straight away you can say. Next question. So with this, what you can understand, you are getting maximum questions from Werner's theory, CFSC, and coordination compounds, isomerism. So in everything is important. That's why we are doing all the different types of questions. Next question. Which one of the following does not give a white precipitate with silver nitrate solution? White precipitate means it should not form precipitate with silver nitrate. So silver chloride should not form. If silver chloride should not form in this, does not form. So which in which complex compound silver chloride is not formed? Let us check the answer now. So this is based on theoretical question. Answer D. In this, silver chloride does not form. In all the others, because this ionizable should be there, the chlorine should be present outside. Here you can see, here chlorine is not getting ionized. As chlorine is, because everything is given in, everything is given in the coordination sphere. So all the chlorines are present in coordination sphere. No one chlorine is also present outside coordination sphere. So definitely this will not form silver chloride precipitate because the chlorine should ionize. So here no ionization takes place for D. So answer is D. Next question. The hybridization of iron in potassium ferrocyanide is. So this is nothing but what is the oxidation state of iron here? It is +3 or +2. So it should be +3. And cyanide is strong field ligand. So potassium, this is 3 plus x minus 6 is equal to 0. Implies iron is equal to +3 oxygen state. So it is ferrous. That is not ferrous, it is ferric. So it is ferric ion here, potassium. So the hybridization of this complex could be, how to find the hybridization of complex compound by using this. So it contains coordination number is 6. Since coordination number is 6 is nothing but octahedral complex, and this is strong field ligand. So it will form definitely D2sp3, and the answer could be D2sp3 because it forms octahedral complex. Very important, octahedral complex first thing. They'll form sp3d2 or d2sp3, and moreover Fe plus 3, it contains unpaired electrons, and it is Cn is strong field ligand. Strong field ligand means it will form inner orbital complex. Inner orbital complex means it has d2sp3, low spin complex. So this is purely based upon this is purely based upon valence bond theory. So from valence bond theory, you are getting more number of questions. So please follow valence bond theory clearly. Everything I have explained in the lecture neatly, easily you can understand that. Next question. Among the following ions, which one has the highest paramagnetism? Among the following ions, which one has the highest paramagnetism? So we can just check number of unpaired electrons. More the number of unpaired electrons, more the number of unpaired electrons, highest is the paramagnetism. High is highest is the paramagnetism. So from this you can easily understand the question. So answer. So first you have to, for this answer, what is the hint? Basic hint is to find number of unpaired electrons. So number of unpaired electrons is maximum in the case of second case because iron in +2 state. So Fe+2 state means Fe+2 means D5 configuration. D5 means N is equal to 5. So answer is B. Answer is what? It is B. Next question. So all the best models we are doing, even in the lecture, and apart from this, we are doing the best. So please note it down carefully. Next question now. The complex nickel cyanide taken 4 times 2 minus has linear structure, tetrahedral, square planar, octahedral. So this definitely this coordination number is 4. Since coordination number is 4, coordination number is 4 means it will have either tetrahedral or square planar. Since nickel is involved, definitely it should have square planar structure. So answer for this could be, so coordination number 4 means it is square planar. It can be square planar when it will take square planar if it is undergoing DSP2. When it will take tetrahedral structure, it is undergoing SP3. So with coordination number 4, these two are possible. Which is two are possible, B and C are possible. But since nickel cyanide taken 4 2 times minus is there, since it is again strong field ligand, low spin complex. Low spin complex means again DSP2, strong field ligand. So definitely it will undergo DSP2 hybridization because they will have paramagnetic character. They will have what character? paramagnetic character. So please note down all these things. Everything is being linked up. Which of the following is paramagnetic? Again, you have to underline this is potassium ferrocyanide, potassium ferricyanide, hexamine cobalt trichloride, tetracarbonyl nickel tetracarbon. So first I'll write the formula. Potassium ferrocyanide is K4FeCN taken 6 times. This is the formula. Potassium ferricyanide is K3FeCN taken 6 times. So definitely this will have paramagnetic in nature. And hexamine cobalt trichloride, that is nothing but hexamine cobalt trichloride. So it is CO, NH3 taken thrice. It could be Cl3 outside because cobalt is plus 3, ammonia is neutral ligand. And tetracarbonyl, so this should be NiCO taken 4 times. This already we know. The oxidation state of nickel is 0. So let us start now. So we can find the number of unpaired electrons in each and every case, and this becomes potassium ferricyanide. As I already told you, potassium ferricyanide ion is in plus state, so it is paramagnetic in nature. Definitely, it is paramagnetic in nature. Paramagnetic, very important. Next question. Which of the following is paramagnetic in nature? Again, the same thing here. Also, we need to identify the unpaired electrons. So NaCl4 2 minus will have unpaired electrons, so it is paramagnetic in nature. Because the oxidation state of nickel is plus 2, here it is 0, and here it is again plus 2, and here it is also again plus 3. But very important thing is here Cl4 weak field ligand. So in here cyanide for strong field ligand. So strong field ligand should be there for paramagnetism. I think the option is not C, it should be D. It should be B because strong field ligand. Strong field ligand means inner orbital complex. Inner orbital complex means definitely it has paramagnetic in nature and low spin complex. So answer is B only, it is not C. Please check it out. Note down all these things in your classwork. Next question. Only a few questions are given wrong. Maybe printing mistake is there. So due to printing mistake, I'm correcting here. So you also please correct in your slides. Which one of the following complexes is diamagnetic in nature? Diamagnetic means no unpaired electrons. So N should be equal to 0. No unpaired electrons. What is N? N is called number of unpaired electrons. So answer for this is cobalt plus 3. So cobalt in plus 3 state is diamagnetic in nature. So this is diamagnetic in nature. Next question. Which of the following complexes does not have tetrahedral geometry? Tetrahedral geometry means coordination number should be not equal to 4. So this is coordination number equal to 4. This is 4. This is 4. Everything they have given 4. But nickel carbonyl is having diamagnetic and it has 5 unpaired electrons, and nickel cyanide is diamagnetic again they have given, but this has unpaired electrons, and nickel chloride is 2 unpaired electrons. So definitely which will have unpaired electrons, that is not tetrahedral shape. So answer is NaCN4 taken 4 times. This is tetrahedral shape because it is undergoing sp3 hybridization. Sorry, dsp2. Exception, this is one exception, very important. So please note down. Nickel tetracyano compound is tetrahedral, not tetrahedral in shape. It is square planar and it is diamagnetic in nature. The complex PT and NH3 taken 4 times 2 plus has dash structure. So what is this hybridization dsp2? So it should be sp2 square planar. Straight away we can see because it is undergoing dsp2 hybridization. Wherever platinum is there, it will involve d electron. So dsp2 and coordination number is equal to 4. Coordination number is equal to 4 means square planar. Because coordination number is equal to how much? It is 4. So answer is A. There is no doubt in it. Next question. So many questions we are discussing. So please note down the coordination number of copper in the complex formed by adding excess of ammonia in copper sulfate solution is excess of ammonia in copper sulfate solution. So it can form along with Q plus copper NH3 taken 6 times SO4. So it can form like this also. So maximum it can form up to 6. So answer it could be 4, 3, 2, 6. So it is because 2 is going away here. So answer is A. Answer is what? It is A. Next question. Amongst nickel carbonyl tetracarbonyl nickel 0 and tetracyanonickelate 2 and tetrachloronickelate 2, which are diamond, which are pyramid. This question is very, very important. This is exceptional question. So please note down the answer easily. You can get the answer also. So first one is what? Tetracarbonyl nickel and 0 and tetrachloronickelate 2 are diametric and tetrachloronickelate. Both are same given. Maybe the option is wrong. This should be NaCN 4 times. NaCN taken 4 times 2 minus. So diametric and this is parametric. So answer is A. Answer is what? It should be A definitely because we have seen that answer. So it should be A. No, C it is given. So nickel tetracarbonyl is diametric and this is and these two are parametric in nature. Exceptional case. Very, very important this bit. Next question. So these questions you have to be thorough with it. Very, very important questions. What will be the spin only magnetic moment of manganese H2O taken 6 times plus 2? So how to calculate spin only magnetic moment? Mu is equal to root of n into n plus 2. So what is the oxygen state of manganese here? It is plus 2. Plus 2 means what is the atomic number of manganese here? Manganese atomic number is 25. So 25 means this will be argon 4s2 3d5. 3d5 means here. So 4s2 means Mn plus 2 means it becomes 3d5. Only 3d5 because 4s0 will come. So 3d5 means 5 unpaired electrons. 5 unpaired means root of 5 into 5 plus 2. Root of 5 into 5 plus 2. 5 2s are 10. It should be root of 5 into 5 plus 2. So 5 7 is 35. So answer is root 35. Option D. This we already, so we have to find the oxygen state first, then we have to write the configuration. So two electrons are removed, so definitely it will go from s orbital. So 3d5, 3d5 means number of unpaired electrons n is equal to 5. Since n is equal to 5, mu is equal to root of 5 into 5 plus 2. So it is clear now. Very, very important. This type of questions is easy. We have done many questions based on this model. Which of the following is not colored? So it should be diametric in nature. First thing, it should be n is equal to 0 or it should be diametric in nature. Then only they are colored, colorless. So we have to identify that this thing. So answer is B because in this cadmium is plus 2 state. As I told you already, cadmium in plus 2 is colorless because it is diametric. Because for this cadmium plus 2, if you see, it is 0. Zinc cadmium HOE plus 2 state, it is n is always equal to 0. So if n is equal to 0, it is diametric in nature. So it is diametric means no color, it is colorless. No color means it is colorless. So please note down all this. Next question. So oxygen state is a key factor for paramagnetism, diamagnetism, colored or colorless. The geometry of tetracarbonyl nickel and nickel, this is triphenyl, diphenyl. So it is uh, phenyl phosphine, diphenyl phosphine, and dichloro are both square planar, tetrahedral, and square planar geometry. Anyway, the coordination number is 4, but this is 6 actually. Anyway, it is 4 only. So 4 here and 4 here. So coordination number is 4 means definitely it will have square planar and tetrahedral. So the possibility is, since in both the compounds coordination number is equal to 4 and here also coordination number is equal to 4. Since tetrahedral and square planar respectively, both tetrahedral, square planar and tetrahedral respectively. So first it should be square planar, second it should be tetrahedral. Both, you can just check it now. So answer is square planar and tetrahedral. First anyway it is square planar and this is tetrahedral in shape. Very, very important. Please note it down. The correct order of hybridization of central atom in the following species: ammonia. Ammonia, we already know it is sp3. platinum DsP2. So it is sp3 here itself. I write platinum DsP2, and this is PCl5. This is sp3d straight away, and BCl3 it is sp2 straight. This is the answer. sp3, DsP2, sp3d, and sp2. So DsP2 only for platinum. So where we have second one, this is the answer. Option B. This is a mixer question that is from coordination compounds as well as, so sp3 ammonia we know, DsP2, sp3d, dsp2. Simple question. Next question. Among nickel carbonyl compound, nickel cyanide and nickel. This question is coming so many times, very, very important. So please listen carefully. Thus, hybridization states of nickel atom are respectively. So in this way, it is anyway dsp2 we know. So this is dsp2, sp3, and this is also sp3. So dsp2, first one dsp2 definitely. So answer is option D. Option D. This B they have given sp3, dsp2, and sp3. So it is correct only. It is option B only, because this is sp3, this is dsp2, this is again sp3. So you should remember certain things from BBT, valence bond theory. So answer is B. Next question. The number of unpaired electrons in D6 low spin octahedral complex is low spin. Low spin means definitely it has strong field ligand. Strong field ligand. So number of unpaired electrons in low spin octahedral complexes, it should be 0, because low spin means strong field ligand. So even though it contains strong field ligand, low spin means what? Strong field ligand. Strong field ligand means here it is octahedral complex. So definitely number of unpaired electrons even in D6 it should have 4, but due to low spin it is 0. Very, very important. Next question. Which of the following systems has maximum number of unpaired electrons? D4 octahedral low spin, D6 tetrahedral, and D6 octahedral low spin, D9 octahedral. So definitely low spin is nothing but it has number of unpaired electrons less. So answer could be D6 tetrahedral, because it is containing 4 unpaired electrons. 4 unpaired. This is 1 unpaired. And this could be 4 unpaired. This is also 4 unpaired, but due to low spin, the unpaired electrons become 0. Become 0. So that's why answer is option B. Very, very important question. Next question. The complex ion which has no d electrons in the central metal atom. No d electrons. Very, very important. So you have to see the configuration. No d electrons in the central metal atom is chromium atomic number 24, manganese 25, iron 26, cobalt 27. So we can find the oxygen state of manganese here +7. It is clear. And here it is +3. This is also clear. And here it is +3 again. And here it is +3 again. So definitely manganese +7 means all the electrons are removed, because manganese configuration, if you see, atomic number is 25. So it is argon 3d5 4s2. And if you remove all the 7 electrons, because manganese in +7 state in a manganate ion, so it should be equal to only argon. All these are removed. So no d electron is present. So answer is first option. Directly we can say easily, this is first option. So electronic configuration plays very important role in all the chapters. So this is the question now. I hope you understood clearly. So with this, I'm finishing my lecture. And which areas we have to do more questions, you have to understand it. So now I'll do summary of the topic. So please note down summary of the topic, summary of the chapter now. We have successfully completed coordination compounds. Now I'll write summary of the chapter. So first we have naming of organic compounds, sorry, naming of complex compounds, nomenclature, naming of complex compounds, IUPAC naming of complex compounds, very, very important. Definitely you'll get one question. Second, we have what we have after this based on IUPAC nomenclature. So the rules are very important. Naming of complex compounds, IUPAC nomenclature, rules are very important. And second point in this, we have Werner's theory, various theories of complex compounds. So we have Werner's theory. And third topic we have, what is the third topic we have? We have done valence bond theory, which is very, very important. Valency bond theory. And fourth topic we have crystal field splitting energy. Crystal field splitting energy, that is CFT, that is crystal field theory. Crystal field theory, which is also very important. And fifth topic we have, after this we have bonding in metallic carbonyl compounds. Bonding in metallic carbonyl compounds. Carbonyl compounds. And sixth topic we have uses of complex compounds. Uses of complex compounds. In all the cases, we have done the maximum and most important points in this. First one is most important. Definitely have to do at least 30 questions in this. Then only you can get master in this 30 questions. Second one, it is less important. At least 20 questions you have to do from other books. And third one is very, very important. Third and fourth are most important. And sixth one is most important. So these areas, except fifth, the remaining all areas, you have to work out more questions. Then only you can become master in this topic. So very, very important. That's why I'm giving all this important information to you. So please do it, all these things. And now I'm ending this session. So this chapter is successfully completed. So we'll come up with next new chapter. So I hope you understood everything clearly. You have to thoroughly follow what we discussed in the session. So please follow all the instructions we given by us and do more questions from complex compound. Definitely you are going to get 2 or 3 questions from this chapter. So with this, I'm ending this session. Thank you all.